Here's a new problem. An object moving in a straight line has a constant acceleration of positive 4 meters per second squared. If the displacement after 8 seconds is positive 176 meters, what was the initial velocity? An object moving in a straight line has a constant acceleration of positive 4 meters per second squared. If the displacement after 8 seconds is positive 176 meters, what was the initial velocity? I hope you can see here that this S stands for seconds. This is 8 seconds. S is the standard abbreviation for seconds. And this M stands for meters. M is the standard abbreviation for meters. Now I'd like you to do two things. First of all, I'd like you to copy this entire problem into your notes. Make sure you copy it carefully and accurately, because I'm going to erase it from the board. And then I'd also like you to try the problem. Now remember that you're not just trying to get the problem right. This is an easy problem. I hope it won't give you much trouble. You're trying to get it right using the systematic 5-step approach that we've talked about before, using the same notation we talked about on the last problem. If you're having difficulty with this material, the solution is to have a systematic approach and consistent, good notation. So please pause the video and give that a shot. You can see that it's crucial that you've copied the problem into your notes so that you can follow along with it as we work through the problem together. Remember, our goal here is not just to learn what the right answer is, but to learn a systematic approach and good notation. All right, step one is to draw the path. But again, for this one-dimensional motion, the path is really boring. We're just going from one place to another place. So I made dots for the initial and final position. So we can simply choose an x-axis that's parallel to that path. There's not too much that's interesting about that either. And since we have one-dimensional motion, there's no components, so we don't need to worry about step 3. All right, now the key here, the step I hope that you definitely didn't skip, was writing out the 5 variables. By this point already, I hope that you've got memorized the 5 kinematics variables. You write down the variables, and then you write down the givens in the question. So let's just go through the problem from the beginning. A truck has a constant acceleration. That's what tells us that we can use this kinematics approach. Remember, if it wasn't constant acceleration, we couldn't even use this approach. A constant acceleration of positive 4 meters per second squared. Okay, now again, we're not going to bother writing down the units here because they're just standard units, but you must write down the sign. We're writing down the sign for all positive numbers. If the displacement after 8 seconds is positive 176 meters, we're not going to write down the units, but we should write down the sign. And again, we're not writing down the units for simplicity, but maybe if you can do the problem with all the units, that's actually fine too. We're just leaving the units out to really simplify things, but if you want to include the units, that's okay, as long as you don't find it confusing. All right, what was the initial velocity? That's the question. Notice how we just read through the problem word for word, and every time we came across a given value, we wrote it down in the right place. And every time we came across the question, we wrote that down in the right place with a question mark. A lot of the time, people kind of miss information in the problem. They don't notice important information, so I recommend using this approach. Just read through the problem word for word, and every time you come across a given value, write it in the correct place. And every time you come across the question, write that down. Of course, you're only going to come across one question usually. There might be more than one question, multi-step problem. All right, so now we've written down the variables, the givens, and the questions, so we've accomplished what we called step 4. Are we ready for step 5? Are we ready to pick an equation? Well, remember, we're ready to pick an equation when we know 3 of the numbers. Well, we do know 3 of the numbers. This one, and this one. Oh, so it looks like I actually did write down the units here, but I'm going to be consistent and erase these. We're not going to write down units. Okay, we don't need the sign here. We don't need the sign for time. Time is always positive. We do have 3 numbers, so we can pick an equation. Now, how do we know which equation to pick? The easiest way, remember, is to ask which variable do we not care about? Well, this is the variable we don't care about. Maybe I'll cross it out. to remind me I don't care about it. So now I can just look at my list of the 5 equations, and I want to pick the equation that does not include the final velocity. Pick the equation that does not include the final velocity. Delta x equals v initial x times the time plus 1/2 a sub x t squared. I think this is the same equation we used on the previous problem. Okay, so this is the equation that does not include the final velocity.